Hi, welcome. My name is Vernanda Anugerah Putra. My metric number is 185110, and now I am going to explain how to evaluate this equation, this integration right here, with the Riemann sum. So now we have a function of x, and the first thing that we need to do is to find our delta x. And in order to find delta x, the formula for finding delta x is b minus a divided by n. B being 2 right here, a being 0 right here. So now we're going to enter these two numbers into here. Now you might be wondering what n is. N is the amount of rectangle in the Riemann sum theorem, and this number goes to infinity. So for simplification purposes, we are never going to replace this n with any real number, and we are going to leave it as is. So let's put in b, which is 2. We put in a, which is 0, and put in n, which is just n. So now we have our delta x of 2 per n. Now this delta x will be used in order to find our xi, which is our general x, which we are going to replace x later with xi, resulting in f of xi. So, but first we are going to find our xi, which the formula for xi is a plus I, which is a general variable, and we are not going to replace this with any real number because we are going to replace this later with some sum laws. And delta x. And we now know that our a is 0 and our delta x is 2 per n, so we are going to replace both of these variables with the equivalent amount. So a is equals to 0 plus I is just I. We're just going to write I as I, and 2 per n is our delta x. So now we have our xi is I times 2 per n. Now we have our xi, and we have our delta x. Before going into the last step of the Riemann sum theorem, we need to find the f of xi, which means we have to input this xi, which is I times 2 per n, into the original equation. So f of xi is equal to x, which is our original equation. We are going to input this into here. I'm going to replace xi with x. So x is equals to I times 2 per n. So now we have our f of xi. So now we need to basically go to the last step of the Riemann sum theorem. And the Riemann sum theorem goes like this. Goes to limit and goes to infinity sigma n, which is number of rectangle, and I, which is equals to 1, but we are not going to replace this I with 1. And then f of xi, which we know that here, and our delta x, which is 2 per n. So now we are going to input these two, which is our f of xi, into here, and delta x into here. So now let's replace those two variables with the equivalent amounts. So f of xi is I times 2 per n times our delta x, which is 2 per n. So now one of the sum laws dictates that n, sigma n equals to sigma n and I 1 I. This is the equivalent of n times n plus 1 divided by 2. So now we are going to replace the sigma n sigma I with this equation right here. But we are going to get these two numbers out first in order to isolate the sigma I. So now let's write that down. Limit n is equals goes to infinity times 4 n, which is 4 per n quadrant, which is 2 times 2, n times n, sigma n I equal to 1, which is I. Now we are going to replace that with this, so let's just straight place this sigma and sigma I with this equation right here. So we have 4 n quadrant times n plus 1 divided by 2. And we know the result of this is going to be n quadrant, but since this n goes to infinity, these two n could be ignored because we know that n as goes to infinity and it won't exactly affect much. So we are going to ignore these n, since we know this is going to cancel each other out because this is going to be n quadrant. So now we are going to care about these two numbers right here, which is going to give us our results from a division. So this is 1, this is 2. So the result of our Riemann sum theorem for this equation is 2.